Yeah, I gave the new one, Nana. If anyone has that, you can send. Yeah, now I gave the new link. Okay, that you can send. Okay, if anyone has. Okay, na? I think new link is working. Is it correct? Yeah, it's working. Okay, right now. Now you can watch in your new link. Yeah, good. Oh, already posted. Very good, very good. Thank you. Right. Come to here, next part. Here I explained the static friction in detail, what I explained in the previous class. Okay. The self-adjusting frictional force, how it adjusts its value to the applied force. Okay. Now, if you come to continuation, actually, this is the continuation in the today's class, actually. Why? Because all these we just recollected from the yesterday's means in the previous from the previous class. Okay. Now I am asking here, sir, suppose a body is at rest, sir. That is okay on a surface. Okay, that is good. But what I am asking is because of the friction between the surfaces, because of friction between the surfaces, first you applied zero force. So here you got the frictional force is equals to 0 first time. Second time, suppose you applied 5 newtons of force. Still the body is at rest, so static friction is equals to 5 newtons. Is self-adjusting, adjusting its value to the applied force. Third time you applied suppose 10 newtons, and that time also the body is at rest, so static friction is 10 newtons. And fourth time you applied F is equals to 15 newtons. Now the body is in a state almost to come into motion. Okay, almost to come into motion means just if you apply 15.1 Newton. Okay, no problem, Nana Deepali. F is equals to 15.1 Newton if you apply, then the body comes into motion, not at rest. Means this is the maximum limit of the applied force to keep the body at rest. Maximum value is frictional force also. You will get same 15 newtons. Why? Because since the body is at rest, okay, still the body is at rest by applying 15 newtons, okay. But if I apply 15.1 newtons, it comes into motion, Nana. That's why it is the maximum force that you can apply when the body is at rest. So at that time, since it is at rest, I have to say the frictional force is also static friction, but it is the maximum value of the static friction. Okay. This maximum value of static friction, particularly FMS, is called as the limiting friction. Why? Because beyond 15 newtons, like 15.1, 15.2, 16, 17 newtons, if you apply, the body comes into motion. Comes into motion means that is not coming under static friction. The body is in motion means the body is not static. Not static. How can you call the friction as static friction? So it is not static friction. That's why it is the maximum value of static friction. Beyond, you will get another type of friction when it comes into motion. Okay, that's why it is the maximum limit for the static friction. So it is called as limiting friction. Okay, that limiting friction they found means FMS depends upon the normal reaction acting on the body. Okay, depends upon normal reaction means I have to write it as FMS is equals to some constant into normal reaction. That constant is represented with the letter mu. That mu is called as coefficient of friction. Okay, I am writing that mu to calculate maximum value of static friction. So maximum value of static friction means it comes under coefficient of static friction. Okay, but keep in mind, once again I am repeating, this maximum value static friction only depends upon the normal reaction. Okay, the other static frictions, they won't depend upon the normal reaction, they depend upon the applied force. Keep in mind. Okay, so anywhere while calculating the Fs don't use the formula mu s into n. Fs is always equals to the applied force only. Okay, if you don't understand this point properly, then there are lot of chances to the mistakes while solving the problems. Okay, FMS is the maximum value, Fs is not the maximum value. Only to find out FMS, you can use the formula mu s into n. Luckily, it is also equal to the applied force at that time. Okay, this one, are you able to distinguish the two, Nana? FMS and Fs? Able to distinguish the maximum value and the value? Yes, 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 good. Right. So will you remember this point? Only for, yeah, good. Only for FMS, we have to use mu s into n. Simple, Nana. Static friction problem is unless and until it comes into motion, the frictional force is static friction. Unless and until it comes into motion means, suppose simple, if I want to push my car to come into motion, you can understand at this example, I think. Okay, Lakshmi Gayatri, to come into motion, suppose to push your, if you want to push your car, okay, in this winter season, sometimes battery fails. So we have to start the car by pushing the car from back. Suppose you understood that my car will just come into motion when I apply, suppose say some 50 newtons. Okay, who is this 50 newtons? When you apply the 50 newtons, that only it tries to come into the motion. Yes, our force, correct only. So still you apply the 50 newtons, the body is at rest or in motion? Till you apply. Yeah, it is at rest. Till you apply 50 newtons, the body will be at rest. Okay, good. This is what I am saying, Lakshmi Gayatri. To find out these 50 newtons, okay, it is the maximum value. Yeah, until applying it is in rest, sir. Acha, until you apply the 50 newtons, the body will be at rest. If you apply 50 point just to 1 newton, then it comes into motion. Okay, now you understood this point now, Lakshmi Gayatri? It comes into motion. So to keep the body at rest, this is the maximum value or not? To find out this maximum value, you can use the maximum value of static friction. You can use mu s into n. But till you apply 50 newtons means I can apply 0 newtons, I can apply 5 newtons, I can apply 17 newtons, I can apply 30 newtons, I can apply 49 newtons. These are not the maximum values of static friction now. They are just the values below the maximum value of static friction. That's why at this instant, if you ask the static friction, I won't calculate by using mu s into n. Simply I say, oh, applied force 0 Newton, static is 0. Apply is 5, static is 5. Apply is 17, static is 17. 30, 30. 49, 49. 50, 50. 50.1, sir, tuch. The body comes into motion, sir. Comes into motion means there is no static friction, sir. You have to give other name for the frictional force. It is not the static friction. Comes into motion. So you have to give other name for it. Okay. Out of all these, all are static friction. To find out whom you are using the formula mu s into n. That's what I explained here. Only to find out 50 or 49 or 30 or 17 or 5 or 0. Only to calculate 50 or 49 or 30 or 17 or 5 or 0. We use mu s into n. Now, yeah, I'm satisfied. So you understood the concept. Good. To calculate the maximum value, that is 50 newtons, we can use the formula mu s into n. Now, is it clear, Nana? So shall I erase this part? Okay, right, good. Okay. In the frictional chapter, the tough concept is static friction, Nana. This is dangerous. Okay. Why it is dangerous? Because until it comes into motion, the static friction is equals to applied force. Every time we have to check whether it comes into motion or not. Okay, this is the disadvantage here, right? Sir, what is this, sir? We can easily identify. We are smart students, sir. It's very easy. We can understand. You give one example, we will say the answer. Okay, sure. I'm giving one example here. Suppose this is a body. He said it is placed on a rough surface. Okay. Its mass is given as, okay, take it as 10 kg, and g this time you take it as 10 meter per second square. And given that mu s is equals to say some 0.2 or 0. Okay, 0.2 coefficient of static friction. It has no units, Nana. Mu s is fms by n. Fms is the force. Normal reaction is also force. Force by force means no units. That's why no units here for mu s. Just 0.2 some value. Okay, Nana. Mu s is given means surely it is rough. Okay. Now I am applying a force of say some 15 newtons. Find the friction between the surfaces. Now you answer the question. Okay. One answer I got from Lakshmi Gayatri. Others, what is your answer? What, Mani Babu? Amok. Yeah, good. Even your explanation is also good. Amok, correct? Two answers. Tanisha, Dipali. Oh, Dipali is in YouTube. Okay, okay. Tanisha, Easter, IHMS is there. Ishan, Rachuri. This time Akhil is not responding. Usually Akhil responds to the answers. MS, yeah. Answer, not yes. Yeah, good. Tanisha again did the mistake. Aditya, what is that? Satvika, correct. Good. Yeah, good. Correct, Nana. Lakshmi Gayatri. Your explanation is also correct. Others, Ore Manibabu Debbalsra. You are just typing a number. Ore, there are only two possible values while typing. Aditya, Akhil, I think went wrong. This is what the other students say. Shrestha, correct. Abba, Aditya. Okay. There are only two possibilities, Rana. If you want to type only, you should type two values, not other values. What are either 15 or frictions are gave one formula. So by using the formula F is equals to mu s into n, that is 0.2 into, since the surface is horizontal, normal reaction vertically upwards, and that is balanced by mg. So I think no need to draw those two. You understood n is equals to mg on the horizontal surface, n and mg. So in place of mg, sorry, n, I substitute mg here. This is, you will get 0.2 into m, that is equals to 20. One possible. Or, sir, I am thinking that the body is at rest, sir. The body is at rest means static friction is equals to applied force, sir. So that is equals to 15. So if you want to post either 20 or 15, not other values. Okay. And here few are posting that the value is 20. Okay. But actually answer is not 20, Nana. This is the complexity that you have to understand from static friction. Okay. What I said, if the applied force is equals to the maximum static frictional force, then write F is equals to mu s into n. That's what I explained here. So I checked both. Applied force is equals to 15. What will be the maximum value of static friction? Here I calculated 20. Means while explaining to the Lakshmi Gayatri, I gave one example. Until you apply the 50 newtons, the body is at rest. In the same way, maximum value of static friction is 20 newtons, means until you apply 20 newtons, the body is at rest. Okay, but I applied unfortunately less than 20. Look at F is less than 20. F is less than FMS, means the body is at rest. Okay, is at rest. At rest means I have to say the static friction is always equals to, clearly I wrote here also, static friction is always not equals to mu s into n, is always equals to the applied force only. That also I wrote here, only. So is equals to applied force. Applied force is 15. That's why my answer, that implies frictional force here is equals to 15 newtons. That is the answer. At least now you understood here non-static friction. Respond please, others. At least now you understood. Okay, good. Then here, better I give one more example. Why? Because here you face a little bit hiccups while solving this problem. So I go with one more example. In the above example, mu s is equals to 0.4 and applied force is 39 newtons. Find the friction. Oh, good. This time Amog responded quickly. Gayatri. Yeah, like Akhil. Yeah, super. Akhil this time responded quickly. Good. Yeah. Abba Manibabu. Lakshmi Sartika correct. Srestha correct. Ishan. Super Ishan. Again, you caught your form. Yes. Charmika. Boo. After a long time. Yashashwini. Yes, correct. Easter. This time correct. Abba Tanisha again went wrong. Ratali. You and Manikanta only putting wrong this time today in the class wrong answers. Why I don't know. But you both are good students. Tanisha and Manibabu. What happened? I don't know. Once again, watch the previous video on a Saturday's class, Tanisha and also Manikanta. Yeah, Varun correct. Good. Tanisha, once again watch Nana, what we are seeing. Yeah, Ishan, you are right. You know everything about Manibabu. Good, Tanisha. This time, I think you corrected. Good. That's a good sign. Ayo, Aditya, wrong, Nana. Okay. FMS is 40, what you are saying, correct. FMS is equals to here, what you are saying, Aditya, that is mu s into n, sir. Of course, horizontal surface, again, n is equals to mg on horizontal surface. And this is 0.4 into mass is 10, g is 10, that is equals to 40 newtons, correct. But this is not the friction. In case of static friction, we have to check every time what is the applied force. Okay. You are taking FMS means, first of all, you check there. What is actually the applied force? Applied force is 39. Again, problem arises. 39 is less than maximum value of static friction. Less than the maximum value of static friction, then the static friction is not equals to the mu s into n. What you calculated here is always equals to applied force only. That implies it is equals to not 40, that is equals to 39. Good. Right, now you understood, Nana? So from the examples and from the previous concept, I think now you understood my pain. Okay. FMS is used to check whether the body is at rest or not. Okay. Right. In one problem, suppose applied force is given as 40 newtons. Then immediately we check with the given value of mu. FMS is equals to how much? And FMS, suppose I got 39. Now I can say, sir, applied force is greater than the maximum value of static friction. So the body comes into motion or at rest. Here in this, good Amog. F applied, yeah, correct. F is greater than FMS. Oh, F applied is greater than FMS. Then the body comes into motion. Yes. Then here FMS, for what purpose you used here? For checking whether the body, to say the body is at rest or in motion. Okay. Suppose in one problem he gave F is equals to 10 newtons. Okay. Immediately we check the value, what the mu value given in the bracket. And with that mu value, we check FMS. Suppose I got FMS is equals to 25 newtons. Oh, sir, the F applied force is 10 less than FMS, sir. Less than FMS means the body is at rest, sir. Here the body is in motion, sir. Means FMS we use not to calculate the static friction. Keep in mind, this is the pain what I took here in all numericals and example, previous concept. FMS used means this formula is used for checking purpose only. Keep in mind. Then in this case, sorry, body is at rest. At rest means again formula is Fs is equals to applied force. So Fs is equals to, sorry, here applied force 10 newtons, sorry, Fs is equals to 10, sir. So is it clear now, Nana, for you all? Is it clear? Yeah, good. Right. So don't do any mistakes, particularly at static friction. Okay. Right. If anyone asks, say FMS or a Badudha, FMS is used to check the thing, the body is at rest or in motion. It is not a formula to calculate the static friction. Okay, static friction is always, you waste fellow, it is always equals to applied force. Okay, directly say by putting your forefinger or middle finger on his face. Okay, right. And I'm going to just by saying one small graph here, I will stop the class, Nana. Right. Here one small graph I'm taking in this page only. Today we took only 2 pages. Here one small graph. Oh, sorry. Here I'm taking. I'm going to draw a graph. Yeah, sure. That obviously takes 5 minutes to complete this graph. Okay. This is one graph what I'm taking. Here, suppose I say it is the x-axis on which I am taking the applied force. and on y-axis I'm taking the friction, but I'm not mentioning what kind of friction. Okay, the friction at rest or the friction in motion. Okay, just friction, that's it. So until now, you know the concept that when the body is at rest, Fs is equals to the static friction is equals to the applied force. It is simply appeared like y is equals to x in mathematics. Friction I took on y-axis, applied force I took it on x-axis. So it is appeared like y is equals to x. Y is equals to x is a straight line or curved line, Nana? Is it a straight line or not? Yes, straight line. Straight line, that too passing through origin. So I should get a straight line like this. Straight line, that too passing through origin. Yes, I'm going to take here a straight line passing through origin. Perfectly. Okay. Will anybody say what will be the slope of this straight line from this equation? Very good. Slope is 1 means x, excellent. Yes, angle is 45 degrees. Yes, exactly. Slope is 1 here. So angle theta is equals to exactly slope angle is 45 degrees. Exactly bisects the 90 degrees, bisecting the angle between friction and applied force. The angle between x-axis and y-axis exactly bisects 45 degrees. And till here, the body is at rest, I am saying. Till you apply this, the applied force is particularly this value. The body is at rest means beyond that force, the body comes into motion now. That's why at that point, the static friction coming to an end. Coming to end means this is the maximum limit of static friction. That's why, shall I say this is FMS in the graph? Yes, exactly. FMS. Exactly. Same. So this is FMS. Okay. Beyond that, if I apply the force, body comes into motion. When the body comes into motion, the friction is called as kinetic friction. Once the body comes into motion, that kinetic friction is constant, not like this Barudhai static friction, self-adjusting. Okay, that is constant. Constant means the frictional force is constant. You should get a straight line parallel to x-axis or not. Constant means friction is. Okay, yeah, parallel. That's why once the body comes into motion, the friction is kinetic, and I will get a graph like this. Okay, a straight line like this. Okay, that time what is the friction is called as kinetic friction, represented with the Fk, where Fk is the kinetic friction. Okay, who is this kinetic friction, sir? How to calculate this kinetic friction? I will explain in the next class now. Okay, do you have any doubts until now what I explained in first page and second page? No, no doubts. No, right. If you want the 2 pages, you can take them now. This is the first page, what I explained today. Okay, thank you. And this is the second page. Okay, I have to say thank you to all for giving buffer time of 15 minutes. Okay, thank you everyone, Nana. Right. Thank you. Tomorrow we will continue the kinetic friction. Okay, bye.